My laptop crashed, so I made this episode on a new one. Things may look a little different as a result. In this lesson we will learn how Unity determines the order of execution of scripts. We learn what problem this order of execution can cause when using a GameManager script. We learn how you can control the order using the Script Execution Manager. We learn how to avoid the problems by using the GameManager's await method. We learn how to set a random value using Random.Range. Let's start this lesson. I thought I finished the last lesson without any bugs in our game. We do not see an error appearing in the console, but the result is not what I wanted to achieve. When I test the game in the editor, I see that the meteor does not start at the top. The player gets stuck in the middle of the screen, and I can't control the player. Everything might work just fine for you, but not for me. If I want to explain what goes wrong here, it is useful to first explain roughly how Unity determines the order of execution of scripts. Let's say we have a game with 3 scripts. All 3 of these scripts contain an awake, start, fixed update, and late update method. Unity will start executing the awake method of the 3 scripts. It's not possible to predict which script gets executed first by Unity. If you do not specify this, it can start with the first, second, or third script. This is where things go wrong in my situation. When all await methods are executed, all start methods are executed, then all fixed update methods, then all update methods, and finally all the late update methods. This is a simplified explanation. If you want to know the entire order, you can consult this flowchart. But for our problem, this flowchart is not necessary. Now that we know how Unity determines the script execution order, we can look at what consequences this can have. In our game we have 3 scripts so far: a GameManager, an enemy movement, and a movement script. We now know that Unity starts executing the await methods of each script. In our case, only the GameManager has an await method. Then the start methods get executed. We don't know which script will be executed first. Suppose Unity starts with the start method in the movement script. In the start method, the function getInStartPosition is called. The getInStartPosition uses the instance variable screen height from the GameManager script. However, in this example, the start method of the GameManager script has not yet been executed. The screen height variable is provided with a value in the start method. So if we want the getInStartPosition in the start method of the movement script to work, the GameManager must be given priority in Unity's execution. If we want to control the order of execution of the scripts, then you can go to the editor and open the project settings. And then click on the Script Execution Order section. By pressing the plus sign, you can add scripts to the list. The execution order is from top to bottom, so first you add the GameManager script, and then confirm by pressing Apply. Now we know for sure that our GameManager script will be executed first. Let's test if this works. The meteor starts at the top of the screen. The player starts at the bottom of the screen, and we can control it. But in our case, we can also solve it in another way. Let's remove the scripts from the script execution order. You can delete scripts by pressing the minus after the script name, and confirm by pressing Apply. Let's open the GameManager script. We create a new function called calculateScreen. We remove the screen calculations from the start method. and passed it in this new function. We call this function in the wait method. Let's add comments in our code. Now the screen calculations take place in the wait method. If we want to access the variables screen height and width in another script, we can do this safely from the start method. Since we are accessing the screen height, in the start method of the movement script, everything should work. It does. Now that we are sure that the order of execution of the scripts by Unity cannot cause any problems, we can continue. At this point, the meteor always falls exactly in the middle of the top of the screen down. But we want it to drop down at a random position at the top of the screen. Let's open the enemy movement script and change this. In the start method, we set the transform.Positions vector 3 on the x-axis to 0. This is why the meteor always starts at the center of the top of the screen, instead of the 0 on the x-axis. We want a random value between the left side of the screen and the right side of the screen. Let's start by creating a local float variable called randomx. We use the randomx instead of the hard-coded 0 on the x-axis. An error occurs because randomx does not contain a value. Let's give randomx the value equal to the left side of the screen. Randomx equals GameManager.instance.screenWidth divided by 2. And don't forget to put a minus in front of it, since we want the left side. When we test this, the meteor should come down from the left side at the top of the screen. If we remove the minus, the meteor will come down from the right side at the top of the screen. Neither is exactly what we want. We want a random value to be determined between the left and right side of the screen. We can use Random.Range to determine a random value between two values. We place the minimal and maximum values between parentheses, separated by a comma. The result will therefore be different every time we run this code. Let's test this out. As you can see, the location is different every time we run our game. So far, the only way we can make a meteor fall is by restarting our game, but we want to make several meteors descend. But that is an assignment for the next lesson. Thanks for watching. In the next lesson, we're making more than one meteor fall down from the sky. I hope to see you back in the next lesson. Please like and subscribe, so you'll get notified if a new video is uploaded. More people will get this video in their search result when they want to learn Unity game development.